Focus for the next 45 minutes. I want to take your current understanding of a function and its derivative and make this tighter, make it stronger. Those 10 relationships that you have on the front page, that is great. You're going to want to keep these handy. The only people you are going to work with, one of you gets to come over here, one of you gets to move. The only people you're going to work with for the rest of the period are the people that you're with right now. Thank you so much, Adriana. All right. So, Adriana, can you read the introduction of this problem?
Analyzing the graph of the derivative. Shown below is the graph of the derivative of a function f of x. The graph of f prime of x has
Sorry.
two.
I meant that to be the word roots. I know there's constantly new vocabulary. Adriana, the good girl that she is, she's like, shoots, it must be a new vocabulary. No, it's an old one. Roots. Keep going. Keep going.
Probably did.
Has roots at x equal -2, x equal 1, and x is equal to 5. Using the graph of f prime of x, determine which statements are true and which statements are false. When determining the truth value of each statement, you must justify your decision. All justification must be based on the graph of f prime of x.
Okay. So, which graph is this? Which graph?
F prime.
This is f prime. One of the ways they're going to mess with your brains on the AP exam, and this is what we're going to focus on for the next week. This is the graph of f prime. The graph in front of you is f prime, and they're going to ask you questions about a different graph. So what I would recommend, now that we've all established that this is the graph of f prime, mark it up. There's some stuff that I told you in the introduction that I want to make sure you're adding onto the graph. So like mark this up so it's super clear. We've got the graph of the derivative. We have roots or toots depending on where you are at -2, at 1, and at, what is that, 5? Yes. Okay. Those are the roots. Is there anything else I told you in the introduction?
Decreasing, increasing.
Well, but hold on, like told you in the introduction. That's it, right?
Yeah.
Okay, so what I'm going to do is I want to give you guys some time to play around with this. I want you to determine if each statement is true or false. We're going to do the first two together, and then I want to get out of your way while you try the next ones. Okay, the graph of f is decreasing on the interval 1, 5. Take 30 seconds to have a conversation with the folks you're sitting with and decide as a group, true or false. If it's true, why? If it's false, why?
True. No. When you have the original function, when it's a negative.
All right.
Oh yeah, this is negative, right?
Negative.
So then okay.
Okay, close it out. 5, 4, 3,
Second half
2, and 1. All right, how many guys would say that this is a false statement? How many guys are going with true? Ooh, that was like everybody's going with true. David, why is the statement true? You're 100% right. Why is it true? If f is decreasing, what's the thing that you know? This is the graph of f prime. F is decreasing. What's the connection? What does that tell you about f prime? F prime is negative. I'll tell you right now, when I'm like grading quizzes and tests, if you can make a connection between the statement and the graph, f is decreasing. Oh, you want me to find out if f prime is negative? That gets you the first point. Because you're showing me that you really understand those relationships. F decreasing means f prime is negative. Is f prime negative on the interval 1 to 5?
Yes.
Right? I'm just asking, am I below the x-axis? So the answer here is true. That's all we're going to do. Okay, another 30 seconds. The graph of f double prime. This is another graph that you don't see.
With the roots from this or maximum and minimum, right?
F double prime.
Are the roots of the next one. So there's 1, 3.
Because that's three different horizontals. Now you're thinking this is original one again.
False?
This is false because they would have one more root here.
Here, here, and here.
It included
We'll take a look in a second. All right, closing out in 5, 4, 3, 2, and 1. How many guys went with true on this statement? False. False. Eunice, why is it false?
I just saw the graph that at x equals 0 and x between 3.5.
Okay, what drew your attention to x equals 0?
The slope is 0.
The slope is 0. Another fancy way you can say this? This graph has a horizontal tangent line, right? H tan over here. H tan over here. And H tan over here. Is that kind of how pretty much everybody made the decision? If f prime, so maybe I'd say something like this. If f prime has a horizontal tangent line, then that means f double prime is equal to 0. How many times is f double prime going to be equal to 0?
3 times.
3 times. At x equals -2, at x equals 0, and at x equals, I'm not really sure what this is. But what I know is a 3rd time. So this is a false statement. We're good? The key is to connect these statements about the graph that you don't see back to the graph of f prime, the graph that you do see. You've got the next 7 minutes. I want you to work only with the people that are with you. If you need any help, let the cups do the talking. I'll come on over.
What is this? What's wrong with this? I'm sorry, you guys.
Yeah, this is right, but it's saying for all the values over here, but these values count too.
What is it doing?
Yeah.
So then it would be true if it said positive, right?
No.
No?
This is correct.
It's on you
But it
guys.
says, wait. Oh wait, this is right. This is true. Because it's saying,
But then it can come back down like this.
but we don't know that. Because I know for a fact, like, the top half means that it's increasing. I know that for a fact.
Since this is increasing, wouldn't it mean that the other one is positive at this point? It would just mean it's positive.
Yeah.
It wouldn't mean that it's
And it is
increasing.
super important, though, that you take the statement that they're asking you.
Oh wait.
and
Oh, it
connect
means that it's
to
positive.
F prime. So if I'm saying f is increasing, what's
We
the
don't know
connection
It
to
means
F
that it's
prime?
positive. Wait, what?
F prime must be positive.
We're only looking
So now
at
read the statement again.
5 and
For all
over.
values
5
x
over.
greater than
Yeah, I
5,
think it's true
the
too.
graph of f prime is positive, and that
Because it's
is
never gonna go back.
Yeah, from what we can see. Okay, now you confuse me. Okay.
I don't know.
No, I think I know what you mean though. You said it was true, right? Yeah. Because it's talking about.
Oh my god!
Oh, it's on
f
there.
is decreasing means f prime.
Oh, but now it's asking f of x.
That honestly gets you up.
So you're right.
That wasn't supposed to
I
happen.
think you're right.
Because what I really care about is can you make a
Wait,
connection?
then
Let's
it's not false. Then it's not true.
Yeah, then it's not true.
What?
Because it's
Why?
asking for the original one.
It's asking for the original, not the derivative. The derivative, we can tell that it's increasing, but it could still be going.
Sure.
It just had to be positive.
Okay.
Said it and wrote it. Dear God!
No, wait.
Oh, now I'm confused. Okay, I need to draw it out. Me?
The graph of f of x.
Wait.
Because the original has to be increasing for this to be positive. So then if this is increasing, the other one has to be positive. And if it's positive, it has to be increasing. So wouldn't it still be true?
That's what I'm saying. Cause like even this whether like if the graph is over on this side, wouldn't the x always be increasing? Like it's never gonna go back.
I'm picturing it like this. Like, let's say the original
It's
graph.
asking for the original.
I know what I'm saying. Like
Like,
any
if
graph
the
in
original
general.
is increasing, then this has to be positive, right? Like this has to
This
be
is a positive
positive.
slope.
Yeah.
Oh yeah.
Yeah. So then it would be true.
Yeah.
It's true.
Yeah, you guys keep confusing me.
Less ignorant.
But then like what he says kind of makes sense. But then I'm like,
The graph of x. Hybrid. We're moving on.
oh, we are moving on.
Graph of relative maximum. The maximum will be at the zeros, right?
The roots of these, like the roots of these are the relative maximum.
I think so. No, it couldn't be because it would have less roots. It has 3 roots.
I was looking at this last night. Because it's going from positive to negative. If it's the relative maximum.
No, it's false. It just means it's gonna have a root at x equals 0.
But it's gonna have it at other points.
Yeah, it just means there's a maximum there.
Because the roots on here means that it's the horizontal tangent line. But it doesn't have to be a root.
So then these horizontal tangent lines have to be roots for the next one.
The graph of f has a relative.
Oh, but this is asking for the original graph.
Yeah.
So then, no, this is false.
Relative minimum.
The minimum is gonna equal 0.
F prime has to change from negative to positive.
No, wait.
Right, so does f of x.
It has, the original one is gonna have 4 roots.
That's what we're still talking about.
Right, so
It is, right? Because it's the cost of the x-axis right here.
I think it's false, you
It's
guys.
going up here.
because f prime does change from negative to positive.
You can't do all this.
Totally fine. We were talking with him. That was my purpose. Camera ready.
Did we already talk about that? Oh, okay, choose f prime as positive, but f is increasing.
I literally did this yesterday. I don't know.
Okay, what's going on here? We look
Yes,
like,
because the maximum for the original graph turn is basically a horizontal tangent line.
It's false because then if the original one had a maximum at
It's
x equals
false.
0, then there would be a root at x equals 0. So it's false.
if f has a relative max, can you guys show me a relative max? Okay, you guys all drew the exact same thing, which is one kind of relative max.
Oh,
You also have to think about the class point in time, which is, so I don't want you to think, oh, relative max means root. No, relative max means what? What happens with f
horizontal
prime?
asymptote.
Nope. Go back to the front page. What does it mean? F has a relative max. What do you know for sure?
It goes positive to
It's
negative.
positive.
F prime changes spot. At no point did I say equals 0. I said f prime goes from positive, like above the x-axis, to negative below the x-axis. Is that what's happening at x equals 0?
Yeah. Wait.
No,
Or
because this is the graph of f prime.
okay.
Right, this is already the graph of f prime. F prime isn't changing from positive to negative at x equals 0. It's positive before x equals 0, and it's still positive after x equals 0. I know this one's hard because you look at the graph and you're like, relative max, and you're like, it doesn't, but I'm asking you about the graph you don't see. It's the behind the scenes graph.
Okay, now x equals 1. Then that one's true. Because it was positive and negative. Right?
Oh, that's timer. All right. So, before anybody has a total panic attack and you're like, but coach, but I didn't finish. No one actually finished. I didn't think anyone was going to get all the way through except for the folks that decided that writing things actually wasn't important and I could just write true or false. And I think it became T and F. Ugh, takes so much time. All right, number 3, for all values of x with x greater than 5, the graph of f is increasing. We would all say true. What I need to see Jose or somebody sitting near him. F increasing means what about f prime? Positive. Is that true? Yes. When I'm scoring the exams, you get a point for making that connection. Show me the connection. Now, I think the hardest part for every single group that I hit was number 4. The graph of f of x has a relative max. So if f has a relative max, the thing that's true about f prime is that f prime changes from positive to negative. Look at the graph. This is the graph of f prime. Is f prime changing from positive to negative?
No.
F is changing from increasing to decreasing. F prime is positive before 0, positive after 0. So I don't have a relative max at x equals 0, so I'm going to say false. There is a relative max. F does have a relative max somewhere. Who sees it? Where does F have a relative max? I see 1, I see 2 people out of 21, I see 3, I see 4, I see 5. Where does F have a relative max? If F has a relative max, F prime makes a change from positive to negative. Jose, where does that change happen? Where will F have a relative max? At x equals 1, because this is where F prime changes from above the x-axis to below the x-axis. Okay? At x equals 5, what do we have? Look at what's happening with the graph. Not a negative minimum. You're changing from f prime negative to f prime positive, so we call it a relative minimum. X equals negative 2. Talk to your neighbor about this. What's happening at x equals negative 2? I see 2 things happening at x equals negative 2. You need to know both of them. If you're not sure, check what you've got in your notes. No, I'm specifically talking about x equals negative 2. At x equals negative 2. I've heard it from just about all the groups. At x equals negative 2, what's happening? What do you have? What does F have? Adriana, what does F have? Why?
Because it doesn't change sign. The derivative.
The derivative.
Doesn't change sign.
The derivative doesn't change sign. We go from positive to positive. But the second thing, there's 2 things for saddle point. Marvin, what's the second thing?
The derivative equals 0.
The derivative is equal to 0, but it does not change sign. Saddle points, right? We increase, we flatten out, we increase. Derivative goes from positive to 0 back to positive. Okay? I did not expect we were going to get through all the true-false statements. I wasn't even interested in getting through all the true-false statements. I was just interested in getting you guys talking and writing. Epic fail for 1 out of 21, but all the right answers anyway. Hey, you get half the points. That's good. All right, so it's time for a little bit of coloring. And I know, isn't that the best part of the day always? At 4 o'clock, Daisy, I need you to give me the face. At 4 o'clock, I have to stop whatever it is that we're doing. Give me sad face. So I want to help you guys out in the homework this weekend. All right, so you need supply kits. You're going to need an index card or a ruler, and I just realized I don't have one for you, so maybe you can borrow 3 index cards or 3 rulers from a nearby group.
You said index card or ruler?
Index card or a ruler. Index card or a ruler. All right.
Ow.
And these are rulers, still not propellers. Marvin, you look like you're getting into propeller mode. Abraham, you'd be amazed what I would do with that propeller. Okay. All right, we are going deep. We are going into the land of the second derivative. I want to plant this idea deeply. I'm not going to tell you, you're going to tell me. Okay, so way back in the day in the world of, I don't know, maybe Algebra 2, you guys talked about concavity. You know about concavity?
Ah, okay.
Concavity.
Weird angle.
Not cavity in your teeth. Concavity. Let's see what you guys remember. Show me concave up. Concave up. Concave up. Concave up looks like this, right? Concave down? Okay, true or false? If your graph has a relative maximum, then the graph is concave up. False. False. If your graph has a relative maximum, then the graph is concave down.
True.
False.
You weren't listening.
Edgar was like, you were sharpening your pencil and you were like, what? I said relative maximum, right? Can you guys all show me in the air, what did you think? I said relative max and you all thought one thing. Everybody thought this. The statement I made was false because what? Because what? What did we forget about? Because we forgot about the cusp point. With the cusp point, you don't know about the concavity. It could be like the absolute value graph, which is straight, it's not bending. So don't fall for it. Don't fall into the trap. Okay? So here's the thing. You know a little bit about concavity. I bet you guys, like, in the world of Algebra 2, you know that we always talk about concavity when it comes to, what were those functions? With the parabolas, right? Because parabolas are always concave up or they're concave down. That was like baby land. Look at this graph over here. This graph does not have the same concavity all the time. This graph actually changes concavity. There is a place, I'm going to say it's right here. I happen to know for a fact it's here. I built the function this way, where the concavity changes. I'm putting a dotted line in here, not for like vertical asymptote business, but just to split the graph. Concavity over here.
Down.
Concave down, concavity over here. Concave up. Okay, let's make sure that's clear. You've got concave down. And then over here you've got concave up. I'll tell you, there are some graphs that will switch back. They'll switch from concave up back to concave down. All sorts of stuff happen. The place where the concavity changes is what we call the point of inflection. New vocab word there. I want to make sure you get that. Point of inflection just means, this is all that it means, the graph changed concavity. That's it. Okay. All right, now it's time to do a little bit of drawing. On the side of the graph where you have concave down, I want you to create at least 8 tangent lines. One more time. On the side of the graph where the graph is concave down, create at least 8 tangent lines for me, please. So just, I'm going to walk around, I want to check out those tangent lines. The concave down part of the graph, 8 tangent lines. And if we haven't talked about this yet, sometimes when I say tangent line, you need to think tangent line segment. That's okay. But I want 8 nicely drawn tangent lines or tangent line segments. While you're drawing this, I want you to start letting the smarticle particles drive. Is there anything that you notice about these tangent lines?
Horizontal.
8 different tangent lines.
Yes, I've got the wealth. It's 8 different tangent lines.
You need to remember that tangent lines touch the graph just once.
Oh.
Yeah, yeah.
Last class, a couple of folks thought I said tangent function, and they were like drawing like the tangent parent function. It's a little crazy. Tangent line. I want to see 8 tangent lines, and if you already have those, I want you to think like a mathematician. Is there anything that you notice about those tangent lines? I won't tell you. No, Amy, I want you to be careful. With tangent lines, they have to be like just touching the curve, just glancing. They never pass through the curve. So they're like on the outside. So 8, only one of those really is negative. What I do, I picked different points of inflection.
2, 3, 4, 5, 6.
8 different lines. Oh, you did? I'm sorry.
8. 1.
Okay. In 5 years of asking this next question, I have only had one student who actually saw the right connection. And it was Janaea last period, and then she talked herself out of this.
Oh.
So I just want to, what are the things that you're seeing? Rambir, what do you see about these tangent lines?
Is that the tangent line they all have to, any line that goes, if you extend it upwards,
Yeah.
then they're all gonna cross right there. And that way,
Shouldn't have been.
like no matter where you put a tangent line.
I've never thought about that. That could be true. That could be true.
Sorry.
What else are we seeing?
There.
What else are we seeing about these tangent lines? Amy, what are you saying?
The slope is always negative.
The slope is always negative. So anywhere I draw a tangent line, the slope is negative? Do you guys agree with her? Is this tangent line right over here? This has positive slope, right? Thank you. All right, other things. This is not an easy question. Jennifer?
Most of them, they make like an outline around the graph except for the one at the top.
Okay, most of them are making like an outline of the graph, like they're kind of like touching on the outside. Okay, maybe. There are no wrong answers to this question. I just want to like create the space for this brilliant connection to be made. Jose?
You can't do it on the bottom side.
You can't do, I'm not even going to touch that one. Okay, I'm not sure what that meant. Okay, what do I know about the slope over here?
Positive.
Positive. How about over here?
Positive.
More positive or less positive?
More
Less.
Less positive over here?
less positive.
Less positive over here.
Less positive.
Over here?
Less positive.
Zero.
Zero over here.
Negative. Negative.
There is one word to describe what's happening with those slopes. Really positive, less positive, less positive, zero, negative, more negative. What's happening with the slopes? There's one word. And I swear if you say oscillating or cuss point, I'm going to throw my boot. The slopes went from positive to less positive to zero. Marvin, what do you see?
They approach the axis.
Okay, they are getting closer to zero at the max, and then they start moving away from zero. I heard some folks up front say changing. Are they changing?
Yes.
Sure, but they're changing in a very specific way. One more time. Positive, less positive, zero, negative, more negative. What's happening with those? They are decreasing. If F is concave down, make sure you get this captured. The slopes of the tangent line, what did we just say is happening?
Decreases.
Slopes of the tangent line are decreasing. But I think we have a better way to say slope of the tangent line. Slope of tangent line means F prime is decreasing. If F is concave down, F prime is decreasing. Your original graph is concave down. Your slopes, positive, less positive, zero, negative, more negative, are decreasing. And if F prime is decreasing, then F prime prime. F is concave down. The derivative is decreasing. The derivative of the derivative, Jennifer, is going to be negative. When F is concave down, your second derivative is negative. There's also something that's true about the tangent lines in terms of where they're located. They all have something in common. Look at them one more time. Where are every single one of those tangent lines in relation to the graph? Every single one of them, if you do them correctly. What do you know?
They're outside of the graph?
They're outside of the graph, even more specific than outside. A better way to describe their location, they're above the graph. The tangent lines are above the graph. And if the tangent lines are above the graph, one of the things that we do with tangent lines, and we do it a lot, is we use tangent lines to generate estimates, right? Like we've talked about, like that, using it as a tool for estimating. If your tangent lines are above the graph, then your estimates that you're going to get out of the tangent line. If the tangent lines are always above the graph, then the estimate, what kind of an estimate? Overestimate. So this is going to be an over estimate. Not a trivial string of thoughts there. I want to give you guys 2 more minutes to come up with the companion side. So go through the concave up process. Draw those tangent lines. See if you can make the connection. Close out that thought. Yes, Jose, you are absolutely 100% right. I want you to go through the process. Go through the process. Draw those tangent lines. Jose is the great big spoiler. He's like, I am pretty sure it is going to be all the opposite statements. Yes, let's check it out. So draw those tangent lines again. Go through the slope conversation. So the original graph is called that. Concave up, thank you. Thank you for that. Yep. So that's sometimes what we use, rather than saying tangent line, we say tangent line. So then short pieces that won't actually pass through, yes.
Wouldn't this one still be decreasing though?
But the slope here is negative. The next one is still negative, but less negative. Right? So it's not that the line is decreasing, you're thinking about the slope of the line. This is some tough stuff. All right, I think I've seen it on most papers. F is concave up. What do we know about F prime? F prime is increasing. F double prime? F double prime is positive. Tangent lines above or below?
Below. It's below the graph.
Tangent lines are below, and it's not understatement, it's
Estimate.
underestimate.
Oh, AP Lane.
That's okay. That's okay, Jose. Nobody heard Jose Oliva say understatement. No. All right. I'm a giver. I want to help you. Daisy, thank you so much. But I want to give you guys one little bit that's going to help you remember this. Let's put the propellers away. Anthony, you're looking around like, who's using the roller as a propeller?
I'm telling you, he's changing.
Concave down.
Is Yaquan.
Concave up. You might want to add that on to your notes.
I'll
It's a
zoom
quick,
in.
easy way to remember this.
Concave down is sad. Concave up is happy.
Concave down.
Is happy. Happy. Okay, I'm done.
Concave up. How's this going to help?
Wow, Jose.
Oh, they're positive when they concave up and negative when it's concave down.
Concave down.
Let's see what you do there.
Stay with me. Concave down. You've got the sad face. F prime is decreasing, but why this? Why two of these?
F prime is
F
negative.
prime, two negative signs. Second derivative is negative. the happy face, right? You get the plus signs with the happy face. F double prime is positive. For all of my folks out there that are into like body art and body piercing, let's give our happy face a little piercing here. Pick a point of tangency. Stay with me, it's gonna be helpful. They decided they don't want a little stud, they want the bar.
Ooh.
Helpful because? Helpful because that's a tangent line. And the tangent line is below the graph.
Oh, I see what
This guy needs some body art. This one always looks more like a booger, I know. Right? They got the bar. They've got the bar and it's going above their frown. Everybody good?
See.
Okay, so let's talk about the homework this weekend.
Oh, Lord.
There are 9 multiple choice questions that have to do with F, F prime, F double prime. Here's the good news. They are all calculator active. I think there are 3 at the end that say calculator inactive. They are all calculator active. Even better news, Martier, can you head on back there? I want to go through one of these right now.
Witchcraft. Oh.
If you guys need to take out your calculators, number 1. At Martier, your smart board, right? You need a smart board.
She just jacked my calculator.
All right, friends, I know we are 6 minutes away from the weekend. Do not waste this time. Okay. All right, so calculator active question number 1. On which of the following intervals is the graph of x be concave up? Oh, God. On which of the following intervals will the graph of f of x be concave up if f prime equals 5x to the 4th minus 20x cubed plus 10? Be concave up OMG. Don't show this to Ms. Henson, please. On which of the following intervals is the graph of f going to be concave up? Okay? And then I give you f prime. This is calculator active. Have a quick strategy conversation. How are you going to use your calculator to answer this question?
Graph is going to be x to the 5th minus. Logic for this, guys. 5x to the 4th.
Martier, what are your thoughts back there? Do your thoughts involve maybe graphing that function? Yeah, let's do that.
10x plus 10x. Edgar, you're so smart.
All right, can I get some brave soul to share their strategy? We only got 4 minutes. I want to get a good start here. Edgar, what's your strategy?
So like I did reverse the power rule thing. So I got x to the 5th minus 5x to the 4th plus 10x.
Wow. Okay, first of all, what you just said, you said you undid the power rule to get x to the 5th minus 5x to the 4th plus 10x.
See.
That is so worthy of a beast point. Congratulations, you actually just integrated, which is something that the rest of us, we will catch up to you in January. I don't think it's actually helpful though. Okay.
JK.
But it was really good.
Disregard that.
Edgar, that was inspired. Inspired. Because now the upside is you could say, well, if I've got the graph of f, could I graph this, right? And then you could have some concavity conversation so that could work. But I want to get the graph of f prime in front of you because it's all about the graph you can see and my asking you questions about the graph that you can't. So you've got your calculator, you can graph 5x to the fourth minus 20x cubed plus 10. Hit enter. Okay, a good viewing window, you need to have a good viewing window here. I think if you're in Zoom standard, you just see like two almost vertical bars.
Yeah.
Martier, can you show the window? Zoom settings set. X min, X max just went negative 10 to 10. Y min, Y max went negative 150 to positive 100. You don't have to use this window, but I want to make sure you see the graph. Okay, so the question is, where is F concave up? What I'm interested in hearing is, if this is the graph of F prime, how do you use the graph of F prime to figure out where F is concave up? What do you know? Two people? Check your notes. I'm asking you about F being concave up. If F is concave up, the graph that you can't see. Jose, what's true?
For concave up, F prime of X goes up the tan line are increasing.
Okay, is everybody okay with that? If F is concave up, F prime is increasing. I've got the graph of F prime in front of me. Where's the graph of F prime increasing? Don't overthink it. Don't overthink this. This is the graph of F prime. I'm asking you like the algebra 1 level of the question now. Where is this graph increasing? Ramir, what would you do?
I think it's from like 0.3 to for when my graph is like that point.
Oh, so this point. The fancy word for this point is?
Not cusp.
Not cusp. It's a relative minimum. Do you guys know how to find the minimum?
Yes.
Martier, do you know how to find the minimum? So it's menu, analyze graph, minimum. Go a little bit to the, little to the left. Little to the, there you go. Little to the right. It looks like I've got a minimum at x equals 3. And it looks to me like this graph is increasing, so F prime is increasing for x greater than 3 before I get to 3, decreasing all the way. So F prime is decreasing for x less than 3. Stay with me for a second. So what's the answer?
C.
It has to be C, right? The question is about F being concave up. The graph that you can see in front of you is F prime. Edgar, truly inspired thoughts. Truly inspired thoughts. What I want to see for all 9 of these problems, I need to see your graph. Right? You're going to graph it on your calculator. Just give me a quick sketch, and then show me like how are you using the sketch to answer the question. This should not take very long. It should be good calculator skills for the weekend. I'll see you guys.